Hello everyone, welcome to XMath tutorial. In this video we are doing circle theorems, and our main focus is on the theorem which states that a line from center bisects the chord perpendicularly. So in this case we have the word bisects. We need to know what is to bisect. To bisect is to cut equally. You can bisect a line. So when you are bisecting a line, it means you are cutting it into two equal parts. If you are bisecting an angle, meaning we are dividing it, or we are cutting it into two equal angles, then it's bisecting perpendicularly. This word perpendicularly is very important when you are applying this theorem, meaning this line, this is our line from center. Let's say our center is O in this case, and our chord is AB. So this line from center passes through and it cuts the chord. But if it's just open like this, we don't know whether it's bisecting it or not. For us to be sure, we are told that perpendicularly, so there should be 90 degrees here for us to be sure that this side will be equal to this side. So once there is 90 degrees like this, we can say AM is equal to MB like that. You can also apply this theorem in reverse. You can be given these two sides. Let's say you are given side AM and side MB marked equally like this. It automatically tells us that there is 90 degrees here. So now let us prove this theorem and see whether it's true or not. But it's true. Let's see how true is it. So we want to prove that AM is equal to MB. So for us to prove this theorem, we need to construct some lines, which is from the center to point A, which is like this, and this one going to point B. So as you can see, we have created two triangles, triangle 1 and triangle 2. So what we are going to do, we are going to be helped by the Pythagoras theorem to prove this theorem. So we are going to apply Pythagoras theorem on triangle 1 and Pythagoras theorem on triangle 2. Let us consider triangle 1 first. I'm going to call it triangle AMO. By applying Pythagoras theorem, our perpendicular sides is OM and AM. So we can say OM squared plus AM squared is equal to the hypotenuse of this triangle, which is OA squared, also like that. But as we can see on these two triangles, OM is a common side. That is meaning it's being shared on the triangle 1 and triangle 2. So we can make OM the subject here, OM squared. That is going to be equal to OA squared minus AM squared. Then we can keep it like that. We'll see it later. Let's consider another triangle, which is triangle BMO. We are going to do the same thing. OM squared plus MB squared is equal to OB squared. We are going to make OM the subject again, since it is the common side. So OM squared will be equal to OB squared minus MB squared. Then now we have two equations. Let us give the reason for this. For the first one, the reason is Pythagoras theorem. Then the reason for this one is also Pythagoras theorem. Then after that, now this is OM squared, this is OM squared. Both sides will be equal. So this means we can equate the two. This one will be equal to this one. So that's OA squared minus AM squared is equal to OB squared minus MB squared. But as we can see, OA and OB are equal sides because they are both the radii of the circle. So I can say OA is equal to OB. The reason is the radii. Then meaning we can eliminate one of the two. It's either OA or OB. So let me eliminate OB. That means OA squared minus AM squared is equal to, instead of writing OB, I'm going to say OA squared minus MB squared. Then after that, OA squared minus OA squared will give us a 0. They will cancel out. It will be left with negative AM squared is equal to negative MB squared. By dividing with the negative both sides, we'll get AM squared is equal to MB squared. Then we are going to apply the square root both sides to remove the squared. Then square root of am squared is going to be equal to am. Then will be equal to square root of mb squared, that's mb. So we have proved our theorem. Thank you guys for watching this video. I really appreciate for your time. See you on the next video for the next theorem.